this is the battery connection, and here this rail is negative, or you can say ground, and this rail is positive, you can say VCC. And IC, this is IC, and how you can count IC pin diagram. You can count from this cut mark. You can see clearly the cut mark. Here one cut mark is there. You can see clearly this cut mark. Put it as it is placed on your front, and this is your left side, this is your right side. So pin number 1 2 3 4 5 6 7 like this, 8 9 10 is 14. So you can count like this. So you can see in the figure pin number 1 2 3 1 and 2 input supply. You can see here 7486 XOR IC. Pin number 1 and 2 is the input of first XOR, and pin number 3 is the output. So pin number 1 and 2 is the input. So we have to provide input on pin number 1 and 2. So here input, one input terminal, here I have inserted. And second input terminal very close to this. You can see 2 inputs added very close. Third is the output. So this is the output. This is output. So this is output like that. So we have to connect 1 kilo ohm resistor with this. So we have to place like this. You can put this more near, and another component should be resistor in series. 1 kilo ohm resistor like that. We have to connect the output terminal here. So I inserted here. You can see I inserted this resistor. One LED here, positive terminal. This is positive and this is negative. Positive is longer than negative. So again we have to insert positive here, and negative is here. Means positive here, negative here. So this is negative supply. This is negative or ground supply, and this is positive. From output it is positive. You can see here from output it is positive. From output it is positive with 1 kilo ohm resistor series, and again here positive. So LED is connected like that, and here ground, breadboard, here ground. I seen shown like this breadboard rail, positive or negative. Now one thing is remaining, what? To connect VCC and ground for IC. So VCC pin number 14, here 14, last pin is VCC. So we have to insert here VCC, and VCC is here. So you can connect like VCC. You can see LED is glowing. Again we have to connect ground. So 7 number is ground. So I use to ground as here. Here I will insert pin number 7 ground. Anywhere we can connect. So I connected very close. Again here, means it is perfectly given. So LED is switched off. Why? Because these both input terminal are on high impedance. If we will provide 1 or 0 in these two terminals, then we will get the output accordingly. Means if we will provide different input or same input, you can see here I inserted one pin and I inserted second pin also, both 0 0, means both terminal are at same input, then output will be 0. But if we will connect another pin is here, then output is 1. You can see XOR gate here 0, here 1, means here A, here B. So A bar B plus A B bar. A bar means 0 bar 1 हो जाएगा, it will become 1, and B is already 1 plus A is 0 and B is 1, so B bar 0, so it will become 1 high, like that. You can see LED is glowing. But if you will put it out, then it will become high impedance, and high impedance will not provide any output. I will discuss these XOR gate basics, why this high impedance is not giving any output, not giving high output. So this is the sum. This is the sum of half adder. Now we have to connect another IC for carry. Here is the IC we have to connect. So for clear connection, we will put it like this. For clear connection. Next IC I connected here. You can see very clearly. Next IC connected. We have to provide VCC and ground for this IC first. So here we will provide VCC from this rail. I connected this from VCC. You can see what I told in breadboard. Again ground, we have to connect ground. So here 7 number pin should be grounded. So pin number 7, I inserted one wire, and here is ground. 1 2 3 4 5. You can connect here also 5. So it is grounded. You can see these two inputs should be there. So for A I will connect here, and for B also I will connect there. So here I will connect A. I have to zoom. You can see I connected both input here. So this vertically sorted. So 2 inputs are here. I will provide this another IC, means AND gate, pin number 1, and again it will be connected on pin number 2. So this you can see A and B here common, like that. You can see in the circuit here A and B of XOR gate is also A and B of AND gate. That's why I connected this A as first input and B as second input, but we will connect same as I connected in this diagram. So for output we have to connect one another pin here, pin number 3. Just close to this, and for this I have to connect one resistor in series. So here one resistor I inserted, another terminal inserted here, and we will connect one LED also. LED positive terminal with resistor point and negative terminal with this ground. But this ground is fifth or not. So 1 2 3 4 5. Here supply is disconnected from here. So we have to connect this supply, ground supply. This is ground. This ground I made continuous. You can see here ground is coming. So I put one ground here to here. So this ground is continuous. One wire I connected. So we have to provide inputs. If these two terminals, I will zoom out. If these two terminals, input A and B are open circuited, then no LED will glow, but it is glowing means anywhere little bit error in the circuit. So we have to connect 0 0 0 and 0 0 0 both LED off. You can see the truth table for 0 0 0 0 truth table, sum and carry both is 0. You can see here carry, here sum 0, but 0 and 1, here 0 and 1, it is sum is 1 and carry is 0. Again we have to change these inputs. For clear visibility I will put it down. All the wires I will put it down, and here also I will put it down. Both these two terminals are input terminals, so we have to make VCC here 1 and 1, 1 one's VCC. If I did here 0 and blue 1 means this condition 0 1, sum 1 carry 0, this is verified. We have to change, blue is grounded now and white is VCC. Then also blue is grounded and white is VCC, also here 1 and 0. Again both should be VCC. Then what will be the value? You can see both are VCC means both are 1, then sum is 0 carry is 1, and both high impedance when circuited, both LED off. If any one of them is grounded, then also it is off. If it is glowing means somewhere it is starting, and if it will provide VCC then glow. If it will provide 0 then both 0, this condition sum and carry 0, here 0 you can see. So this is the implementation and output of the half header. For good connection I will explain how it is connected. These are the input terminals at A and B. You can see here input terminals A and B, 1 number 2 number pin, and this input terminal is connected with one another wire here, and another B is here, so it will go in AND gate. Here AND gate IC, here one wire is connected with this A terminal, and from B terminal it is connected here. So here you can see A and B, here A white, B blue, here A and B. You can see these two wires is going here. A and B, and here output is here with register, here going with register and LED, and for this AND gate output is purple here. Thank you. If you have any query then comment in my comment box, and for this battery if you will put it like open circuited then it will discharge through air maximum, so you have to put like this, then very less discharge will be there like this, because this is isolated. So you can put like this. So please like, share and subscribe my channel.